Find the equation of the oblique asymptotes, they say. All right, can do. Long division's pretty great. We know these have oblique asymptotes, by the way, because look at the degrees. Second degree over first degree, yep, that's one more, and second over first again. So yes, these will both have oblique asymptotes. There's no trick questions here. The way we find the oblique asymptotes is by doing a long division, or we divide the numerator by the denominator. Now, having said that, do you see why we don't need to do a long division for this first one? Because there's just x here. We can long divide that without going through the whole production. We can just say 2x squared divided by x is 2x, and 3 divided by x is like so. And so when the limit as x goes to infinity, this is the part that will vanish, right? Any parts that are divided by a power of x, where you have what we call a over x to the n, just a number over a power of x, those parts will vanish. They'll become so small that we can ignore them. And so the oblique asymptote is the part that doesn't vanish, the 2x. So our oblique asymptote here would be the equation f of x equals 2x. For this next one, we are going to need long division. We have to do 3x squared minus 7x divided by, I'll throw in a plus 0. I'm not positive we're going to need this, but I'm always reminding you to make sure that you have all your powers of x in descending order. And so if we have second order, or second degree, and first degree, technically we should have a space for things of 0th degree. And our divisor is x minus 2. So x goes into 3x squared 3x times. Multiply and we get 3x squared, of course. And then we get minus 6x. And then we subtract. 3x squared minus 3x squared, gone, as intended. Negative 7x minus negative 6x is like negative 7 plus 6. That's negative 1x. Bring down the 0, I guess. We might have been able to get away with not having this 0, but I'm trying to be a good boy and follow the book. So bring down that 0. Now, x goes into negative 1x, negative 1 times, and that gives us negative 1x. Negative 1 times negative 2 gives us plus 2. I guess it's good that we have this column for the whole numbers, or that 2 would kind of have no place to go. And we do negative 1 minus negative 1. That cancels. 0 minus 2 is negative 2. And so our finished thing is that f of x is 3x minus 1. That's the quotient. And then minus 2 over x minus 2. This part is a constant divided by a power of x. This part will vanish. When x gets uncountably big, 2 divided by x will become undetectably small, so we can just say we'll ignore this. The function will essentially behave like 3x minus 1. So, by the way, okay, I cheated a little bit here and I feel bad about it. Here I do not mean to say that the function f of x is 2x. What I mean to say is that the oblique asymptote will have the equation 2x. And here it would be best to say that the oblique asymptote has the equation 3x minus 1. The function doesn't exactly go to this, it just gets extremely close to it. That's more like it.